Have you ever used a map to find your way or played a video game with a coordinate system? If so, you've already experienced the power of coordinate geometry. This branch of mathematics bridges the gap between the physical world and abstract concepts. Coordinate geometry helps us describe the position of objects and their relationships with each other. It provides a framework for understanding shapes, distances, and movements. By using a simple grid system, we can translate real-world locations and objects into mathematical language. Imagine a treasure map with an X marking the spot. The map uses a grid to pinpoint the treasure's exact location. This is the essence of coordinate geometry, using coordinates to define positions in space. From finding your way around a city to designing complex structures, this system has countless applications. Whether you're a math whiz or just starting out, understanding coordinate geometry opens up a world of possibilities. It's a powerful tool for solving problems, making sense of data, and navigating our increasingly complex world. So buckle up and get ready to explore the fascinating world of points, lines, and shapes on a grid. In coordinate geometry, we use a system called the Cartesian plane to represent points. The Cartesian plane is like a giant graph paper with two perpendicular lines, the x-axis, horizontal, and the y-axis, vertical. These axes intersect at a point called the origin, 0, 0. Each point on the plane is represented by an ordered pair of numbers, x, y, called its coordinates. The first number, x, tells us the point's horizontal distance from the origin. The second number, y, indicates its vertical distance. For example, the point 2, 3 means we move 2 units to the right from the origin along the x-axis and then 3 units up along the y-axis. Think of it like following directions on a city grid. Go 2 blocks east and 3 blocks north. By using this system, we can precisely locate and describe any point on the plane. Whether it's the location of a building on a map, a star in the sky, or a data point on a graph, coordinate geometry provides a powerful tool for pinpointing positions. Points are the building blocks of shapes, and lines are the simplest shapes we can create by connecting 2 points. In coordinate geometry, we can describe lines using equations. The most common form is the slope-intercept form we equal sign mx plus c. In this equation, m represents the slope of the line, which tells us how steep it is. The slope is calculated as the change in y divided by the change in x between any 2 points on the line. A larger slope means a steeper line. The CE in the equation represents the y-intercept, which is the point where the line crosses the y-axis. It tells us the value of y when x is 0. Imagine you're drawing a line on a graph. The slope tells you how much to go up or down for every step you take to the right. The y-intercept tells you where to start drawing your line on the y-axis. By understanding the equation of a line, we can predict its behavior, find other points on the line, and even determine if 2 lines will intersect. One of the most useful applications of coordinate geometry is calculating the distance between 2 points. Whether it's the distance between 2 cities on a map or the length of a diagonal line on a graph, the distance formula comes to the rescue. The distance formula is derived from the Pythagorean theorem, which states that in a right triangle, the square of the hypotenuse, the longest side, is equal to the sum of the squares of the other 2 sides. In coordinate geometry, the 2 points and the origin form the vertices of a right triangle. The distance formula states d equals sign x2, x1, 2 plus y2, y1, 2. Here, x1, y1 and x2, y2 are the coordinates of the 2 points, and d represents the distance between them. By plugging in the coordinates, we can easily calculate the distance. This formula has numerous applications, from calculating the distance traveled by an object to determining the proximity of 2 objects in a simulation. It's a fundamental tool used in various fields, including physics, engineering, and computer science. Section 5, circles, round and round we go. Circles are everywhere, from the wheels of our cars to the ripples in a pond. In coordinate geometry, we can describe circles using equations based on their center and radius. The standard equation of a circle is I and x, h to 2, plus y add k2 equals sine r2. In this equation, hk represents the coordinates of the circle's center, and r represents its radius, which is the distance from the center to any point on the circle. Imagine drawing a circle with a compass. The center of the circle is fixed at a point, h, Ka, and the radius determines how far the circle extends outwards from the center. This equation allows us to determine if a point lies inside, outside, or on the circle. It also helps us understand the relationship between the circle's center, radius, and any point lying on its circumference. Section 6. Equations in action, real-world applications. Coordinate geometry might seem abstract, but its applications are deeply rooted in our everyday lives. From GPS navigation to computer graphics, these equations are constantly at work behind the scenes. Consider GPS navigation, a technology we rely on daily. GPS satellites use coordinate geometry to pinpoint your location on Earth's surface. By triangulating signals from multiple satellites, your GPS receiver determines your precise latitude, longitude, and altitude, guiding you to your destination. Another example is computer graphics, used in video games, animated movies, and medical imaging. Designers and animators use coordinate geometry to create and manipulate objects on a screen. Each pixel on your screen is assigned coordinates, allowing for precise control over the placement and movement of characters and objects. These are just a few examples of how coordinate geometry silently shapes our world. From tracking airplanes to designing bridges, its principles are applied in countless fields, making it a truly indispensable tool in the modern age. Section 7. Lines in technology, from GPS to gaming. Remember, the equation of a line is not just a mathematical concept, it plays a crucial role in technologies we use every day. Let's explore how lines, represented by their equations, are employed in GPS navigation and video games. GPS navigation heavily relies on line equations. When you enter a destination into your GPS device, it calculates the shortest route using algorithms based on coordinate geometry. Roads and paths are represented as lines or curves on a map, and your route is determined by finding the most efficient sequence of lines connecting your current location to your destination. Video games, especially those with 3D environments, extensively use line equations for graphics, rendering, and gameplay mechanics. For instance, to determine if a bullet fired by a player hits a target, the game engine uses line-line intersection calculations. The trajectory of the bullet is represented by a line, and if that line intersects with the line or surface representing the target, a hit is registered. These are just two examples of how the seemingly simple concept of a line, represented by its equation, has a profound impact on technology. From determining the shortest route to simulating complex physical interactions, lines in coordinate geometry are essential building blocks of the digital world. Section 8. Circles in technology, from radar to Wi-Fi. Circles defined by their center and radius also play a crucial role in various technologies. Let's delve into how the equation of a circle is employed in radar systems and Wi-Fi networks. Radar systems, used for detecting aircraft, ships, and weather patterns, rely on the properties of circles. A radar station emits radio waves in circular patterns. When these waves hit an object, they are reflected back to the station. By measuring the time it takes for the signal to return and the angle at which it was received, the radar system can determine the object's distance and location using the circle's equation. Wi-Fi networks also utilize the concept of circles to define their coverage area. A Wi-Fi router emits signals that propagate outwards in a roughly circular pattern. The radius of this circle represents the range of the Wi-Fi network. Devices located within this circular area can connect to the network, while those outside the radius will have weak or no signal. These examples demonstrate how the simple equation of a circle has significant implications for technologies that shape our lives. From tracking objects in the air and at sea to enabling wireless communication, circles in coordinate geometry are fundamental to our increasingly interconnected world. Section 9. Coordinate geometry, a powerful tool for understanding our world. From the maps we use to navigate to the technologies that connect us, coordinate geometry is woven into the fabric of our lives. It's a powerful tool that bridges the gap between the physical and digital worlds, allowing us to understand and interact with our surroundings in new and innovative ways. By representing points, lines, and circles with equations, we gain a deeper understanding of their properties and relationships. We can calculate distances, determine intersections, and predict movements with precision. This ability to quantify and analyze spatial information has revolutionized fields like engineering, architecture, and computer science. As technology advances, the applications of coordinate geometry continue to expand. From self-driving cars that rely on precise location data to virtual reality experiences that immerse us in simulated environments, this branch of mathematics is shaping the future. So the next time you use your smartphone to find your way, play a video game, or connect to Wi-Fi, remember the silent power of coordinate geometry at play. It's a testament to the elegance and utility of mathematics in describing and navigating our complex world.